we're going to look at is corresponding angles. So in red, I'm just going to go down the line. I'm going to color in my corresponding box in red. And my two corresponding angles are right here and right there. Be patient while you're sharing your markers with each other. I want everyone's corresponding angles to be red. So once you get yours colored in, pass it to the person next to you so they can color it in red. I don't want anyone switching up the colors. So I want it to all be nice and consistent. Make sure you're coloring in the right angles. Probably should have waited to glue this in case anyone makes a mistake, but I think you guys got it. And just like we talked about yesterday, I'm going to kind of talk and teach while you guys are coloring. So if you are the one not using your marker, make sure you're listening up. Everyone should be listening, but you know. So corresponding angles are like a translation. If I have this red angle down here, and I just slide that angle up, boom, I see my corresponding angle right there. Red angle, red angle. So they are in the same place. Hopefully we remember translations enough to see. Corresponding is usually the most confusing angle pair for us to kind of wrap our minds around, so I wanted to get that one done first. That's what our corresponding angles look like. And corresponding angles are equal to each other. If this red angle on the bottom is 110 degrees, how much is this red angle on the top? 110 degrees, right? If they're equal, they'll be the same angle measured. So now vertical angles aren't the only ones that are going to be equal. Corresponding angles are equal as well. Another relationship that is equal is our orange relationship, alternate exterior angles. There's my alternate exterior angles in orange. Pay attention to the way I'm coloring it. Let's not do that, please. We got something to color. Only color in this little sliver orange, because that other half we're going to color something else. So just match exactly what I'm doing. Both use orange. Just be patient, share it. Remember, the term alternate exterior gives us two very important pieces of information when it comes to finding out what these angles are. Alternate means that they're on different sides of the transversal. So this bottom orange angle is to the left of my transversal. This top orange angle is to the right of my transversal. An exterior means that they're on the outside space of my parallel lines. This bottom orange angle is below my parallel lines. This top orange angle is above my parallel lines. So we can see that these are alternate exterior angles. We would also have alternate exterior angles on the other side as well. Right? Flip-flop. Because they're alternate. Opposite sides of the transversal. And alternate exterior angles are also equal to each other. Good morning. Next one, again, this is something we know. We've been talking about it. We're going to color it in yellow. Thank you. And that is our vertical angles. Yes. Vertical angles right here in yellow. Those little slivers of angle arcs.
I'll look away for split with color.
And if we remember how we know vertical angles, we know that there are two angles that are directly across from each other, forming an X, morning, forming like a bow tie type shape. Well, we could also think of them now as there's one on the interior, one on the exterior, and they're on opposite sides of the transversal. You can think of it one of two ways, whatever way makes more sense to you. Here you go. But again, vertical angles we've been working with. Should be fairly comfortable identifying those by now. So Darius, let's keep those on the desk, please, sir. Thank you. Vertical angles, as we know, are equal to each other. We don't really need to go over that again. Next up, our fourth angle pairing in green, same side interior. This again gives us a lot of information just in the name. These two angles in green are on the same side of the transversal. If we cover up the left side of my transversal, I see they're both on the right-hand side, same side, and they're on the interior of my parallel lines. I cover up the outsides, boom. We can see that they're on the same side of the transversal, and they're both on the interior of my parallel lines. We'd also have same side interior angles on the left side of my transversal and both on the interior. Right, so there's multiple pairings of all these angle types, these angle relationships. Now, same side interior angles, these are actually supplementary. Go ahead and write supplementary above that equals 180. You can write it in pencil, I don't care. Take a look. This top green angle that I'm pointing at, is that an obtuse angle or an acute angle? It's obtuse. It is larger than 90 degrees. What about this green angle on the bottom? That one's acute. So if this angle's obtuse, this angle's acute, they cannot be equal to each other. They are in fact supplementary. We can add them together and they equal 180. Next, we have alternate interior angles. It's going to be these two little ones here we're going to color in blue. Alternate interior angles. They're on opposite sides of the transversal. One's on the left, one's on the right.
Is that blue?
It is blue. And they are on the interior of my parallel lines. These are also equal to each other. And the last angle pairing we didn't really talk about yesterday because we're not going to be tested on it. It's not super important, but just to finish it out in purple. Same side exterior. Again, the name tells us everything we need to know. These angles are on the same side of the transversal. And they're on the exterior of our parallel lines. Does that help? Perfect. Same side exterior angles are also supplementary. So this is an important thing for us to know. So if you've been talking the whole time, I'd suggest stopping just for at least 30 seconds so you can hear what I'm about to say. Okay. The only angle relationships here that are supplementary are same side angles. Same side interior, same side exterior. So just think, same side supplementary, SSS, same side supplementary. Everything else is equal. So if we're going to set up an equation, which we will tomorrow, we're going to set them all equal to each other unless we have a same side supplementary relationship. Then we're going to add them together and set them equal to 180. So hopefully having this nice and color-coded will be helpful for us when it comes time to using this on like a test or a worksheet or something as a resource, especially when I'm not around. Once you get that finished up, you can put your markers away. Make sure all 10 of them are in there, please. Then we'll take a look at some examples. That is 110 and B. Thank you. All right. Let's take a look. So we've all got this relationship drawn now. Guys, thank you. So the first thing we need to do is figure out what relationship we're looking at, right? We can ask ourselves a couple questions. The first question being, Are they interior or exterior angles? That'll narrow down our choices super quickly. What does it look like based on this image? Are they inside those parallel lines or on the outside of those parallel lines?
Outside.
Outside. So what type of angle are they?
Exterior.
Exterior. Bless you. Yep, bless you. Exterior. Right? So now we know from our list of options, they've either got to be alternate exterior or same side exterior. Well, if I'm looking at my transversal now, we're going to ask, are they on the opposite or same side of the transversal? Easy way to do that is cover up one half of your transversal. Can I see both of those angles? No. All I can see is angle B. If I cover up the other side, can I see both angles now? No. All I see is 110 degrees. So are those on the opposite sides or the same side?
Opposite.
Opposite. So what can we call this relationship here? I shouldn't have wrote opposite. That's my bad for confusing you. But it means the same thing as opposite. It starts with an A. Alternate exterior. They should just be called opposite exterior, but whatever. I don't make the rules. I just teach them. Alternate exterior angles. So that's our relationship here. Looking back at our color-coded diagram, are alternate exterior angles supplementary or equal?
Equal. Supplementary.
Take a look.
They're equal.
They are equal. How can I tell? Well, just look at it. Alternate exterior is equal. Okay, we could also see these are both obtuse angles. They're both greater than 90 degrees, which means that in this relationship they are equal. So we're going to set them equal to each other. B, fellas, B equals 110 degrees. One angle on the left, one angle on the right. And that's our answer. That's all we got to do. There's nothing to solve here, nothing to subtract from both sides. That's just what it is. B equals 110 degrees. How are we feeling about that? Quick show of thumbs, how we walk through that process. Obviously, you don't have to write all this stuff when you're working, but this is what you should be thinking about. Okay? And if you're talking right now, don't bother asking me a question when we get to the worksheet. You'll figure it out. Let's take a look at this one.
Oh. Are you talking about that one, the one that took me to that looked like a student? Oh, that one? I know what you're talking about now. The one with the girl.
So, is it only supposed to be interior or exterior? Like between those two?
We'll get to that because there is a middle option where it's both, right? Let's take a look at this one. We're going to ask ourselves the same thing. Interior or exterior here?
Interior.
These are interior. Are they on the same side of the transversal or are they on alternate sides? Same side. So what can we call these? Same side, interior. That one is a much easier name, hopefully, to remember. They're on the interior of the parallel lines. They're on the same side of the transversal. Same side, interior. So, are they supplementary or are they equal? Supplementary. These ones are supplementary. Again, we can tell that they're not equal because A is an obtuse angle and 57 degrees is an acute angle. If they're different types of angles, they cannot be equal, but they do add to 180. So, we could say A plus 57 equals 180. That's what it means for two angles to be supplementary, like we talked about. Now, angle A and 57, unlike what we talked about in the previous lessons, these are not adjacent angles, right? They are across from each other. They're not lined up in a typical way that we would identify as supplementary, but they still add to equal 180. How can I get A all by itself now here? Minus 57. What's 180 minus 57? 123 degrees. Okay, last but not least, we're going to take a look at, I don't have room. I'm sure I do. I'll make it work. What's that? This picture? Yeah. That's what everything's going to look like. It's parallel lines cut by a transversal. Thus the name of the lesson, parallel lines cut by a transversal. They're always going to look like this. They might be horizontal, they might be vertical sometimes, they may be a little bit diagonal, but like on the worksheet, that's what they all look like pretty much. Just the transversals cut it at a different angle. It still makes the same relationships. All right, let's ask ourselves our question. Are these interior or exterior angles? Both. 99 degrees is on the interior. X is on the exterior. So they're both interior and exterior. Are they on the same side of my transversal or alternate sides? Same side. They're both to the left of my diagonal line. If you don't know how to answer that question, just cover up one side. If I can see them both, then obviously they're on the same side, right? So what relationship do we have that is on the same side, but there's one in and one out? Corresponding angles. We look back at our notes yesterday. Corresponding angles are on the same side of the transversal, one interior, one exterior. Everything you need to know is in your notebook right now. Are corresponding angles equal or supplementary? Equal. They're equal. So we could say that x is equal to what? 99 degrees. So on the worksheet, you're going to have to name the relationship and find the missing angles. Yeah. Pretty much. Just we're looking at a different type of image, but it's the same kind of thing.